Right, today we're going to talk about data logging. Proper data logging, as I would call it, for condensation, mould related issues, damp issues. Now, lots of people claim to be a damp expert, and people get involved in these disrepair cases, and it can be very expensive. So we get involved in lots of these problems that have been going on for a long time, and everyone's getting a bit grumpy about things. So, in my opinion, these are best resolved by producing some decent data. Now, if you're looking at producing some decent data, you personally, in my opinion, need some data loggers in various rooms. You also need an external data logger for measuring vapor pressure outside as well, and so you can convert that to make sure you can see exactly what's going on with vapor pressure inside, so you look at the differential or the excess. You also really need a surface temperature measurements in maybe a couple of places. So the surface temperature measurements are going to show the temperature of the wall, and then you can put that comparison with the dew point in the room, so you can actually see where these meet and prove condensation occurs. So I'm just going to give you a little bit of a basic demonstration on the graph. So on the bottom of the graph here, you just can have the dates. Now, all of my readings are normally taken every half an hour. So you've got your temperature here, and this is the relative humidity here, and then you've got temperature, dew point, relative humidity, and you can see you've got lots of spikes, as to be expected. This is the bathroom, so you can see what time everyone's having a shower. Basic stuff on here. It's really, really good. You can see it. Put a trend line through there if you want. You don't have to put it on and take it out. You can, and also you can do all this for the living room, bedroom. You can go into the kitchen. There's so much you can get on there. And I'm just going to give you an example, like the data. You're just getting thousands of pieces of data. I think there's like 2,000 there. We've done a data logging over, so it's quite a period of time. So this is an example here. So the blue line is the dew point, and the red burgundy line is the surface temperature. So where these meet, condensation occurs. So as you can actually see, there's no exact pattern what's going on where the condensation is occurring. So for me to turn up at the exact day condensation has occurred in the exact time, it's probably not going to happen. Although we know the best time to do a condensation survey is first thing in the morning, because that's when it's more likely to happen, because most people know when you're getting condensation on windows, it's normally first thing in the morning, in the early hours, and after they've got up for a couple of hours, normally it's disappeared. So this just highlights the principle of using a surface temperature measurement, because otherwise you're not going to see where condensation occurs. Differential vapor pressure. Now, normally, if you're getting what we found, roughly, if you're getting about 0.5 kPa and above, you've got a ventilation issue. So that's the excess or the differential vapor pressure from outside. So this is all the moisture produced above the outside moisture. Now, as you can see here, there's some massive spikes. So we're just going to look here. So the purple, as you can see, these big ones here, that's the kitchen. So you can expect big spikes here. Now, 5:30, as you can just see, 4:30, 5:30, 5:30, 5:30, 6, 12:30, 5:30, 5:30, 6 o'clock. We now know what time people are eating their dinner. This is when they're cooking. But what's really interesting is when you start putting the cursor around, you can start to see. So as we can see here, you've got massive vapor pressure, huge at 5:30. But if you also just take it across a little bit, so that's 8 o'clock. So these levels are going up, and it's just ridiculous. Now, I carried out a survey on this property, so I know basically the building fabric is dry. I've done a lot of thermal imaging here. I've done a lot more analysis on what's going on with the ventilation. Now, the kitchen fan is not working properly. There's not sufficient trickle vents so there's not enough background ventilation, and there's also not enough undercuts in the doors. Noticeably, the kitchen. So if you could imagine, this is why these problems are occurring. I'm just going to show you another one of the same property. So on here you can see again lots and lots of data. So we're looking at the our relative humidity, the RH of the room is 55%. Relative humidity surface is 87.4. Now 80% of the time the RH was 83%. The average wall temperature is 14.7. The average surface relative humidity is 84.5. Now we can also calculate it -5, -10, -15, -20, just to see what sort of numbers we get. So once you've made all these spreadsheets up, it's pretty easy to do all this sort of stuff, and you can just produce marvellous and marvellous amounts of data. So I'm going to give you another example of property here. Again, long-term issue, not been resolved. So you're looking at temperature, RH and dew point again here, but this is another little clever thing you can do. So this is surface temperature has been put onto the storage heater, so we can actually see here that there's no heating has been used for 3 days, but after that it's consistently good, you know, very high. These are the old storage heaters. But I just want to show you another little thing on here as well, just explaining why you're getting these problems sometimes in these areas. So we're looking at stuff and we're calling it the boundary layer. So on here the blue line is the living room relative humidity, so this is like generally around the living room. The red burgundy line is at the base of the wall where there's a lot of mold problems. Now this is a big thick wall in this property and it was damp, you know, old building, been bodged up over the years. But what I'm just trying to show you here is you see the distance between these two. Now this was in March. As you can see here we're going into July. Now you can see this gap. Now you see it gets smaller and they reach equilibrium, but at some points the relative humidity difference between the room and the boundary layer was like 30%. These are massive differences, massive. You're normally going to always get 10-15%, but some of these you're getting like 30%. You know, you got big vapor pressure difference. This is the outside. One of these is the living room, bedroom. One of these is the hall. You know, huge differences again. And this is down to ventilation as well. And obviously the building's got some damp issues. But you can produce all these graphs here. In my opinion, just by producing all these graphs here, you get everything resolved so quickly. What we also do to certain clients, the housing associations, we actually now give them a guarantee that they're not going to get condensation on their walls as long as we do a proper survey. If necessary, do a bit of do a bit of data logging and get all the ventilation, everything bang on. Sit down, talk to the tenant, go through everything. The job's resolved. But just to say, thanks for watching this. This is a sort of service we can offer. So if you do have problems and you want to get to the bottom of it, this is what we can do for you. Thanks for watching.